Hello everyone, let's learn semiconductor device with Rainy. Today I'm creating this video to explain you all about BJT. Let's break it. Before enter to our topic, let me introduce myself. I'm Rainisha. My registration number is 01DEE24F1154. Bipolar junction transistor is the full form of BJT. I know you all eager to know the function and significance of BJT. So let's see. Here we can see various shapes of BJT that we use in electrical circuit. BJT has three top semiconductor regions separated by two p-n junction. The main function of a BJT is to current control device used for amplification and switching. The BJT significance as signal amplification and switching applications in electronic field. This video consists of three objectives. That is, the first one is to identify the transistor's electrode, which is terminal. The second one, the NPN or PNP type of bipolar transistor. Finally, the silicon and germanium type of bipolar transistor by using multimeter, ohm range. BJT terminals and its function. BJT consists of three terminals, which is collector, base and emitter. And we also can see the schematic symbol of BJT. Basically, the topmost terminal in schematic symbol is called collector, and the middle terminal is base. Finally, the terminal that leads downward is named emitter. Each terminal has its own function. First of all, emitter sends out charge carriers into the base region. It is heavily doped to supply a large number of carriers. Next, base controls the transistor. It is very thin and lightly doped, allowing only a small fraction of the carriers to pass through to the collector. A small current here controls a larger current through the transistor. Finally, collector collects charge carriers from the emitter that pass through the base. It is moderately doped and larger in size to handle heat and high voltage. In simple terms, emitter sends current, base controls current, collector receives current. That's all for the function of each terminal. Let's learn how to find the three terminals by using multimeter. Our first procedure is to find base terminal. Before start the experimental procedure, plug in the red probe of multimeter to the negative COM output and the black probe of the multimeter to the positive output. The main important thing is don't forget to calibrate to get an accurate value. Imagine that the first one is terminal 1 and the middle one is 2, the last one is terminal 3. The first step is put the red probe to the first terminal and the black probe to the second terminal. The multimeter shows infinity reading. Without changing the red probe position at the first terminal, move the black probe from the second terminal to the third terminal. The multimeter still shows infinity. This time, change the first terminal to black probe, touch the red probe to the second terminal of the transistor. The reading value is 85 ohm. Without changing the probe position at the second terminal, move the other probe from the first terminal to the third terminal. We will get the same value, which is 85 ohm. The third step is touch the red probe to the third terminal of the transistor and touch the black probe to the first terminal of the transistor. Without change the position of the red probe, move the black probe from the first terminal to the second terminal. This is the data we got from the experiment. If both of the readings on the meter show a deflection about 20 to 500 ohm, this indicates that the terminal of the transistor is the base. In this case, frankly, we can see that the terminal 2 is our base. Not only that, we can easily find the emitter and collector terminal. Let's find it. Before start, Do as usual method, which is ohm range setting and calibration method. Touch the black probe to the base and the red probe to the first terminal. The reading show infinity. If you change the position of the red probe to the third terminal, we can see the terminal F value. This means the terminal that gives a lower resistance is the emitter, the higher one is the collector. Let's find BJT types, either it's NPN type or PNP type. If the types in schematic symbol, we can easily find that either it's NPN or PNP by just see the arrow. Let's discuss about the differences between these both types of BJT. PNP type have a small negative voltage is applied to the base. First of all, in PNP type condition, because of it starts with P positive, holes move from the emitter to the base and into the collector. And then the collector collects the holes, create current flow from emitter to collector. NPN type have a opposite working condition of PNP type. Touch the red probe of the multimeter to the base and the black probe to the collector and emitter. At the same time, the multimeter display the value. This experiment explains that if the polarity of the probe that touches the base is positive, then the transistor is an NPN type transistor. If the reverse polarity applied, it indicates a PNP type transistor. So the experiment is related to NPN type transistor. Let's find the material of BJT. Before we go for the experimental procedure, let's see what is the explanation of both materials. From the four common aspects, which is leakage current, temperature use, base emitter voltage, and availability. Silicon have a very low leakage current. It also good at high temperature. The base emitter voltage of silicon is 0.7 volt and very cheap. Germanium have a high leakage current. It also not good at high temperature. Base emitter voltage of germanium is 0.3 volt and the availability is rarer and more expensive. Touch red probe to the emitter terminal while the black probe to the collector terminal and observe the resistance reading on the meter, and then change the meter probe and repeat the step and again observe the resistance reading. If both readings show a high resistance reading, then the transistor is a silicon type transistor. If it's a germanium type transistor, the meter reading will show a high resistance reading and a low resistance reading, or vice versa. Finally, we enter our last part of this video, which is conclusion. BJT consists 3 terminals named collector, base, emitter. We learned that BJT have 2 types, that is NPN and PNP. Lastly, the material of the BJT, silicon and germanium, but mostly use silicon because has low leakage current, is cheaper and stronger, needs 0.7 volt to turn on, and high temperature. The real-world application of BJT is amplifiers, switches, and oscillators. Well, that's all from me. Thanks for watching my video. I'm pretty sure that viewers learned some new information today. Like my video if you enjoyed. Share to people who you love most. And don't forget to comment in chat box. Thank you.